Welcome and good afternoon, everyone. Thanks to attending today and being part of building the bridge to sustainability in the refrigeration world, where the new A2L range products of INTARCON will be the bricks of this bridge. The refrigeration industry has been a pillar of our society, guaranteeing standards that have allowed us to develop and increase our quality of life, from preserving food to cooling large cool rooms. But for decades, this progress has had a cost. The environmental impact due to traditional refrigerants such as HFCs and CFCs. Nowadays, we are at a historic turning point in the refrigeration industry, where the choices we will make today will be key in the future, in the transition to this future. So A2L refrigerants are not just an alternative. They are the bridge, as I said before, that connect us to a cleaner, more sustainable, and more efficient future. So, are you ready to cross? Here we can see the contents that we are going to see today. The main drivers such as environmental, regulatory, and market. The main features of A2L refrigerant, and the portfolio of products that INTARCON will land today, with the commercial semi-compact A2L equipment and the compact commercial A2L equipment. And finally, we will see some case of study with success stories. Let's see the main environmental, regulatory, and market drivers. Our journey toward a more sustainable future began in 1987 with the Montreal Protocol. That was an international agreement which tried to fight the destruction of the ozone layer depletion by protecting it and reducing the production and consumption of ozone depletion substances. Next, in 1997, the Kyoto Protocol sets emission reduction targets for the major industrialization countries, and the European Union too focused on greenhouse gases. But the failure of the global adoption of this protocol meant that the Doha Amendment to this protocol to further enhance this commitment was not adopted, and wasn't until 2015 with the Paris Agreement that in this year becomes a key year with this agreement, where we set even more ambitious targets on energy efficiency and renewable energy, to focus on keeping global temperature rise below 2 degrees Celsius, above pre-industrial levels. Next, in the next year, through Kigali Amendment, that modify the Montreal Protocol, represents the world's largest contribution to stopping the global temperature rise. Different regulations are aligned with the vision that this agreement has, both national and European level, such as, for example, in Spain, the RECIF, or in Europe, the F-gas, or even standards such as EN 378 that serve as a guide for the standardization and harmonization of the sector. In summary, the main drivers are, the first part, greenhouse emission reductions, where climate change is one of the biggest challenge we face today. And A2L refrigerant appear to contribute directly to mitigate this global challenge. Next, the F-gas regulation. With the entry of this regulation, we not only face the regulatory challenge and the limitation of the commercialization of HFCs, but it's really an opportunity to innovate and stay ahead of the future. Finally, we think that today sustainability is not an option. In fact, the stakeholders, from customers to manufacturers, are looking for responsible targets and solutions to drive a positive change on the planet. That this solution must be aligned with the values of the companies. It's important, this graph is the market quota of the new F-gas in 2024. Here we can see this reduction schedule that was agreed through the various environmental agreements that we said before. This graph is important to understand in order to know how the sector has evolved towards low GWP refrigerants in Europe. This will be the same scenario to the rest of the world. In addition, Europe wants to lead this emission reduction and created the F-gas in 2014, but was in 2018 when the prices of refrigerants in Europe rose due to the speculation of the reduction of supply in the market. So finally, experts contemplate low GWP refrigerants to be able to put in the market more kilograms of refrigerant with the same emission of tons of CO2 equivalent for those production. Otherwise, if we continue using refrigerants with high GWP, the available amount of kilograms of refrigerant in the market will be much lower. If we maintain the demand, consequently, the price of this refrigerant will rise. So the first consequences of the quota reduction that affect all of us, and today that we are going to dive into, are the compact equipment with GWP higher than 150 after January 2025, that is this month, and split units with the same GWP that will be affected after January 2030. So the solution that will be viable for compact equipment will propane and A2L, and split units, A2L, CO2, ammonia, propane. Let's see. So in summary, this market driver are in the first part, the regulation as we said before, the availability and price, because of A2L's ensure medium-term stability in price and supply for this refrigerant. Next, energy efficiency, because A2L refrigerant has a higher energy efficiency than most HFCs. And finally, the ease of installation and maintenance for the installer. The transition to A2L is simple and accessible, eliminating resistance to change for the installer, because of he has the experience and the expertise to work with this technology. So natural refrigerants such as propane or CO2 are used in a wide range of products, but installers that would be looking for a more cost-effective solution could maintain this conventional system, because of H2 refrigerant is an excellent option to change from HVC to a refrigerant that has a lower GWP. Despite their physical properties, which are similar to HVC, the flammable characteristic must be considered. So it's the main feature that A2L has. But first, we have to make the question what is an A2L refrigerant? The capital letter designates the toxicity class. It's not a toxic refrigerant. The number indicates the flammability, and it's updated, as we know, with the inclusion of the new subclass 2L for slow burning class 2 refrigerant. And this is, first, flame spread limit at 60 degrees, and atmospheric pressure is lower than 10 centimeters per second. It's very low. The lower flammable limit is higher from 0.1 kilogram per meter cubic, and the heat of combustion is lower than 19,000 kilojoules per kilogram. So what does these factors translate into the practice? A2L refrigerants requires at least 1,000 times more energy to ignite the most flammable A2 refrigerant. This is the MIE, the minimum ignition energy that the refrigerant requires to ignite. This means that A2L refrigerants are unlikely to be ignited as a consequence. Even flames have difficulty for ignite under test conditions. In addition, the L means that it has got a very low burning velocity. The BV is very low in comparison with other refrigerants. So many times, even in the case of ignition, the flame is likely to burn so slow that even it could be extinguished on its own. Which refrigerants are classified as A2L? The left column, we could see the name. In the right column, we could see the GWP that it has got this refrigerant. And we can see in this slide the comparison of GWP and density according to different refrigerant groups. Mainly, we can see that A2L have a low GWP in comparison with other refrigerants, HVCs, and it has got a density that varies greatly. And also it has got a slight flammability. These features are very important to know because it will be important to the performance of the equipment because it affects to the thermodynamic properties. From INTARCON, we promote the refrigerant R455A with a GWP of 145 because we made a balance between thermodynamic properties and GWP. And with this refrigerant, we achieve the higher cooling capacity as well as we are allowed to get a high refrigerant charge in the circuit. Let's see. In this slide, we are going to compare the main properties of this refrigerant. In the first graph, we can see the burning velocity versus the heat of combustion. And we can see that the A2L refrigerant are close to A1 refrigerant in these properties and are very far from the A3 refrigerant. In the next graph, we see the lower flammability limits that we can see, as well as the minimum ignition energy, are very high for this refrigerant here in the upper right graph. So the main consequence is that due to the ignition point, for example, for these refrigerants A2L R32 and R1234YF, there are many cases that there wouldn't be any combustion, such as, for example, from a cigarette, a lighter, sparks, or even a heater. Another important factor is that the refrigerant charge has a limit in the installation because of its flammability. We are going to see this study according to the EN378, where we classified first the category of premises from public, supervised, and restricted access, the location type of the equipment, the compressor, liquid receiver, but mainly we can divide it into compact equipment, split units, chillers that are in machinery room, and the other. So how we translate this into charge, into limited charge? For example, we can see this table that is a translation that we land for this refrigerant charge with the R45A according to the EN378. At first, we see the public category, public, supervised, restricted. For example, for type 1, that will be the compact equipment that we will see today. We have got a limit of refrigerant charge up to 30 meters cubic, that is 2.5 kilograms. Next, up to 16.5 kilograms, we have to calculate due to this formula 20% per lower flammable limit per the volume of the cooled room. This will be the same case for a split system with public access, and in supervised access we could go up to 25 kilograms of refrigerant in circuits. If the refrigerant charge limit is exceeded, additional measures can be taken also. Here we are going to be an example for a matching room, where we have to calculate the ventilation for this matching room, where we have to know the minimum ventilation and the additional ventilation that will be these lines. And we create 5 different zones. Mainly the first one, A, is the area that we have seen before, if we are below the limits that we told. Next, upper the limit M2, that is 26 meter cubic per lower flammable limit. We have to insert natural ventilation. If we are in the C zone, we have to put an additional protective measure plus leak detection, or even if we are from M2 up to M3 per 1.5, we have to include 2 additional protection measures such as mechanical ventilation, sound alarm, safety valves. Never we shouldn't have a refrigerant charge in this E zone that will be higher than this formula. Even we can see this calculation we can make with Client 360. Let's see how we can do it. For example, for a premise with public access, with a split unit that could be a system location tool for this refrigerant. For example, for a volume lower than 30 meters cubic, let's see, for example, we've got 2.6 kilograms, as we said before, up to 30 meters cubic. Once we increase the volume of the cooled room, we have to calculate with the formula that we said before, up to the limit that will be 16.8 kilograms. In the case we change the premises, if, for example, it's for supervised access, we could go up to 25 kilograms. Okay, even we can see this example for compact units that is in a window mountain. And the calculation is like we see before. Okay, recommend to know more and practice with this tool. Well, INTARCON has developed a new generation of split units specifically designed to make the most of the advantage of this refrigerant. So this is a product that we are strongly committed because we know that will solve the needs of our customer in the near future. So this is the Sigillus unit, SFNN. It's a new product with this refrigerant, a sustainable solution, plug and play system, single phase and 3-phase available with a hermetic compressor, electrical resistant defrost, thermostatic expansion valve. It's totally tested by the manufacturer, and it's a compact design. Mainly, the feature of this equipment are a removal from grid for optimal maintenance of the equipment, where the fan protection grid can be removed for cleaning and access to the fan, a removable fan for better maintenance. This equipment is equipped with quick connector for easy and safe disconnection and removal of the fan. A safety valve is integrated in the liquid receiver and has got an access to this element through the 3-panel design. Next, the connection. This equipment has flare connection that provide a quick and easy assembly process, and thread connection for the safety valve duct. Finally, the control board is located in a separate area from the refrigerator, making it easier to disconnect the unit from the power supply. Here are the standard technical specifications. We have said mainly most, such as reciprocating hermetic compressor, also a liquid receiver with a refrigerant pre-charge for up to 10 meters, safety line with high and low pressure switches, condenser tray, flare connection, crankcase heater for the compressor, drain heating element on low temperature models, defrosting by electrical heating element, expansion by thermostatic valve, conductive safety valve, multifunction electronic control, and circuit breaker protection. Next, we see the options of this equipment: change of power supply to adapt to the main electrical supply, micro door switch to shut down in case of open door, polyurethane and epoxy coating of condenser for external coil protection, voltage monitoring on single phase, voltage and phase failure on 3 phases, hot gas defrost on 1 pipe for efficient defrosting because of we attack to the source of cooling, master slave, liquid side glass, protective grid, condenser control for very low ambient temperature from -5 degrees up to -25 degrees, room LED lights, oil separator that we recommend when the cooling distance exceeds 10 meters vertically or 30 meters overall, and the multifunction control LM660 that is an industrial size display. The electronic control is the XM670K with multifunction remote digital control, internal clock for programming and energy saving cycles and defrost, possibility of interconnection and synchronization of up to 8 devices by LAN. And the main characteristic of the Sigillus equipment is the triple noise insulation, where Sigillus units incorporate triple noise insulation as a standard. Insulated compressor compartments separate from airflow, acoustic compressor jacket, and low noise and low speed fans. This will be the installation diagram, and we recommend a maximum vertical distance between units of 15 meters if the condenser unit is higher than the evaporator. Otherwise, 6 meters in the case that the evaporator will be higher. Here we see the electrical connection that are the same for the SH that we'll see later. We see the probes, manuke, fans, defrost, display, and switch door if it is the case. We also have to insert the drain pipe of 20% for low temperature models to avoid water frozen. So let's see the medium temperature models now for SFNN equipment. We go from chassis 1 and the condenser. We maintain this chassis and we change the chassis of the evaporator, including more fans. We go from 1.3 up to 2 horsepower in the compressor, and we have got a cooling capacity range for a 0 degrees cooled room from 900 up to 3.3 kilowatts. And we see in this column the refrigerant charge that we have got for a pre-charge of 10 meters of the liquid line. We have to ensure that the limited charge is, we are below the limited charge in each case of installation. Now let's see the low temperature models. We have used 1.4 up to 3 horsepower compressors, and a cooling capacity range for a -20 degrees for a cool room temperature from 700 up to 2.4 kilowatts, and the refrigerant charge is always below the limits, the limit of 2.59 that we have seen before. The dimension we can see in this slide, the condenser maintained, and we only change the evaporator. So let's see this equipment in Client 360 and how we can know more point of performance for this unit. In this case, A2L refrigerants. We see, for example, for medium temperature equipment, we see the case. For example, for this equipment, we can calculate for different conditions of cool room temperature to know how it could be performance. For example, for 2 degrees. For a mid-cool room, we can know the cooling capacity and different data. We can also see dimensions of this equipment. And the analysis of the envelope of the unit and the compressor. I aim both of you to prove this tool and make of the calculation that you want. To know more and change in the input data, and you can see how the performance will change. So let's continue with the next equipment. That is the brother of SF. That is the SHH, the interbox equipment. That shares the main features of Sigillus equipment. It's a new solution with A2L refrigerant, a sustainable solution, plug-and-play system with single-phase and three-phase available, with reciprocating hermetic compressor, electrical resistance, thermostatic expansion valve, totally tested, and a compact design. Here, the design we have changed, and the panels, for example, are removable left grid, allowing easier and safer maintenance. We focus totally on maintenance and ease of installation. The control panel is located in a separate area here, improving this access, this facility. Next, the connection that also are with a flare connection, and the safety valve that will be ducted. In this case, it will be in the other hand, in the other part of the equipment, here, behind this part. It shares the main standard technical specification: liquid receiver with refrigerant pre-charge for up to 10 meters, safety line with high and low pressure switches, condenser tray, flare connection, crankcase heater, drain heating element on low temperature motors, conductive safety valve, multifunction control panel, circuit breaker protection. Also, we have got the main options that shares with the Sigillus equipment, and in addition, we are going to repeat the same. These are the same as we said before. We can choose centrifugal condensing fan for hot air conduction to the outside. We can include also the circular duct adapter for circular ducts. Water condition for water loop system or chiller. For in the first case, for an inlet range from 5 degrees up to 50 degrees, and in the second case for a temperature range from -10 degrees up to 5 degrees. And we can also include automatic water pressure switch valve and a solenoid valve water for installation. We also use a non-return valve for avoid liquid hammer and overpressure in the compressor. We use the same electronic control, and in this case, the interbox is born as a centrifugal equipment. That is the concept of this equipment, and we usually use for exhaust duct for condenser hot air. We used to move the hot air that we have created in the area. The installation diagram is similar as we have seen in his brother, and the electrical connection are the same. Now let's see the medium temperature models for the interbox equipment. In this case, we change also the condenser and the evaporator. The chassis will change. The dimension will increase from MSHNN 11 up to 33. We use compressor from 1.3 up to 2 horsepower, and we obtain a cooling capacity range from 870 watts up to 3.1 kilowatts. And as we said before, we have to be in accord with the limited charge that we have in the installation. In the case of low temperature models, we have a cooling capacity in range for minus 20 degrees in the cool room from 700 up to 2.2 kilowatts, and we are always below the charge limit. The dimension we can also see in client 360. So let's see an example with this software. We were here and we are going to select, for example, BSH, a low temperature model, an interbox low temperature model, for example, the bigger one, the biggest. Okay, let's see, let's calculate this performance. For a cool room temperature minus 20 degrees, we can also know more point of performance. Let's see how cooling capacity will change. We could know the dimension to adapt the best suitable evaporator for the cool room space. We also know the unit, the envelope unit and the envelope compressor. I am also to prove this tool, this software, that I know will be very useful for engineering, installers, students, anyone that wants to know more about products or even refrigeration. From INTARCON, we understand that the future of compact equipment will be propane. As we said in the last webinar about CV and CR MPD Pro equipment, that are equipment with propane as a refrigerant, and from INTARCON we know that will be the future of the refrigeration, but we know that transition need time, and we have to supply this time. So that's why we offer two different lines of products that will coexist in time. On the first part, A2L compacts as a transition for compact HFC equipment, and in the second one, compact equipment with propane that we consider that will be the future. We maintain a design that is not the more fashion, but we consider, as we said before, those differences in product lines. We use here the same refrigerant, R455A, as a sustainable solution, available single phase and 3 phases. We also use reciprocating hermetic compressor. In this case, we use hot gas defrost, expansion with a thermostatic expansion valve, totally tested and a compact design. The standard technical specifications are these that I show in this slide. For safety line, high and low pressure switches, condensate tray, automatic condensate water evaporation of the water that we condensate, door heater and low temperature motors, hot gas defrost, 50 millimeters polyurethane from sandwich panel evaporator, multifunction electronic control. Let's see how this control will change. It's not the same as we have seen before. And LED room lights and circuit breaker protection. As option, we can change the power supply. We could select micros door switch, polyurethane and epoxy condenser coating. We can use centrifugal condenser fans for condenser air supply to the outside. Modbus connector to convert the TTL output to an RS485 signal. Supply air to circular duct adapter for centrifugal versions. Non-return discharge valve, voltage control for single phase and 3 phases. The electronic control is the XW270K with multifunction remote digital control, temperature control with maximum and minimum temperature value recording, quick cooling function, and night operation mode for energy saving. The installation diagram, we have both options, plug-and-play frame mounting, a removable buffer for direct window, mounting in the cool room is supplied as a standard, and drop-in frame mounting can be easily carried out by simply preparing a frame for installers and then attacking the ceiling of the room. Let's see medium temperature models. We go from chassis 0 up to chassis 3 with compressor from 1.3 up to 134 horsepower, and we obtain a cooling capacity range for medium temperature from 700 watts up to 2.6 kilowatts. And we are always below the limits of refrigerant charge that we have seen before. Low temperature models, we go from chassis 0 up to chassis 3 using compressor from 3.4 up to 3 horsepower, and we obtain a cooling capacity range for minus 20 degrees. In this case, from 400 watts up to 2.1 kilowatts, and we are always below the limit of refrigerant charge. The dimension we can see also in client 360. So let's see an example of a CV with A2L refrigerant. In this case, we could see, for example, medium temperature CV compact units. Interblock unit, for example, chassis 2. We can calculate different points. For example, for medium temperature, we could choose another temperature, could be, for example, 2 degrees, and we can fastly know the cooling capacity. We could see the dimension of this equipment, analysis of the envelope of the unit and the compressor. So finally, let's see the last equipment that we are going to see today, that is the CR compact equipment, the intertop unit, the rooftop unit. It shares the main features with his brother CV, the interblock. Has got the same characteristic with reciprocating hermetic compressor, hot gas defrost, thermostatic expansion valve, totally tested. The same standard technical specification. And now we change options because we have also the option of vertical discharge for centrifugal fan in this equipment. The rest of the options are the same that we have seen before with the interblock. The control is the same, the XW270K. And the installation in this case is totally different. We first put the fan of the evaporator, and next we assemble the rest of the equipment. And we can see, for example, here a possible solution for a cool room installation. Let's see the model that we have selected in this equipment. We are going to move from chassis 0 up to chassis 2 using compressors that go from 1.3 up to 1.5 horsepower, getting a cooling capacity range for medium temperature from 700 up to 2 kilowatts, and we are always below the limit of refrigerant charge for the volume of the camera. For low temperature models, we also use, we go in this case from chassis 0 up to chassis 3 using a compressor that go from 3.4 up to 3 horsepower, using a cooling capacity range from 400 watts up to 2 kilowatts, and we are always below the refrigerant charge that according to the cool room volume we are below that from that limit. Finally, we can see the dimension from the mounting frame. Let's see the last case with Client 360. We see also this equipment in the software. We can select, for example, BCRMM, the smallest one, for example. And let's see the cooling capacity range that we will think. For example, we can change also the cooling capacity, the temperature of the cool room, and how fastly we know the performance of this equipment for this point. So finally, let's see some success stories. Here we are in Spain, so I select commercial refrigeration solutions that are closed from INTARCON. That could be, for example, in Córdoba, using a Sigillus commercial refrigeration equipment in a hospital, that is, for example, Reina Sofía. We also use interblock solution in Málaga, for example, a sport club, or even commercial semi-compact units for a market. So thank you so much. I will be glad to attend your question, and we'll try to solve all of them. So let's see if there are any questions. Colin Botswell make a different question. Okay, Colin, for the first comment about the final report about benchmarking risk by A2L refrigerants, the conclusion is about, I read, low burning velocity of 2L refrigerant does not prevent rapid flame spread under many conditions we observed. Okay. Good. Moreover, ignition can occur even when the local air velocity is much higher than the laminar burning velocity. Okay, in the first part, if I go to the table that I show about ignition point with R32, I use the letter D, that is the deflagration, that is what you have said. That is usually H2R refrigerant spreads the flame in a lower velocity than the sound. So that's the main consequence of the research that you expose. That's the first comment. As I said, it's not an explosion. It's not because the velocity is not higher of the sound level. An ignition can occur. Yes, it depends of the minimum ignition energy and the lower flammable limit, and of course of the source of heat. Mainly, there are a lot of tests that shows that there are possibility of explosion and deflagration of some refrigerants. So as a consequence, we have to calculate the limit of charge of this refrigerant due to flammable property. So the next comment, so on the basis of which data do you conclude that H refrigerant tend to have higher efficiency? I haven't included the source that I said the energy efficiency. As you said, your research shows has very similar curves. As you know, H2L refrigerant has got lower thermodynamic properties than HVCs, that it has got a bit low cooling capacity, but it uses less absorbed power, so the COP are very similar, even higher, for all refrigerants except CO2 and H3, that it will be higher. And finally, your last comment. Thank you for it. Why do you express the lower flammable limit in kilograms per meter cubic? I think we use, because it's easier for the installer. It's easy for the installer to use this measure. That's the main case we use. We summarize the total charge or refrigerant that we can use in the table that we see at first. We haven't seen category 2 and 3. First, in this case, we only see categories 2 for this practice. I will check the ISO 817 because we get the standard with EM on the first hand received, that is inherited from EN 317. So I will check it. Okay, Colin? Marco Boysen made the question about if this gas is available for South Africa. I think you should make this question to your distributor, to your supplier, that it could be because that would be supply this refrigerant. As we said, this gas, I don't really know if South Africa is the first main group of countries to the quota reduction. I don't really know, but I have to check it. But as we said, Europe tried to lead the reduction of emission, and South Africa will be affected too to this quota. So your supplier will also have this refrigerant to make the compliance of the tons CO2 equivalent in the production of the refrigerant. Is there another gas we can use on these units? In this case, INTARCON, Marco make the question, INTARCON promotes only the use of this refrigerant. For the use of other refrigerant, INTARCON doesn't guarantee the right performance of the equipment. Colin, thank you for your questions. So I think it would be a nice afternoon with you. Nice to be here. I'm glad to present this new portfolio product for INTARCON that we have made to try storytelling from a traditional refrigerant, HFCs and CFCs that we have used, and we are going to move into natural refrigerants, and the bridge of this transition will be A2L. We know we are going to learn more about this refrigerant, about possibilities with this refrigerant. And we are also focused on make the best solution for our customer and stakeholders. So thank you all of you, and see you in next webinars. See you, bye. Uf. Hostia.